All right, so today we're going to talk about perpendicular and angle bisectors, and we've talked about both of these last semester, but we're going to go a little more in depth with them. Now, I almost wish I had your guys' definition on this paper instead of the one that's on here, but the definition on here for perpendicular bisector is going to be that it's a line segment, or a perpendicular bisector of a line segment is a line that is perpendicular to the segment at its, any idea? It's perpendicular at its halfway point. What's our word for halfway point? Midpoint. Very good. Now, again, I almost would have rather just put the definition that you guys had yesterday, which was that I think it was this table here, said that a perpendicular bisector is a line that cuts a segment in half at a 90-degree angle. And that's another great way of thinking about it as well. So it cuts a segment in half at a 90-degree angle. Okay? I threw this word out yesterday, equidistant. We talked about it like once or twice last semester, if that. Equidistant means same distance, equal distance. It's like the words equal and distance smushed together. So a point is equidistant from two figures when the point is the same distance from each figure. Okay, so yesterday what we did with that string was you saw Mrs. McCrone and I measure from a point on the string to each endpoint of the segment to see if they were the same. And then whoever had the smallest distance was the winner. That was an example of showing equidistance. All right. So that's exactly what these two theorems say right here. This looks a lot like the picture we had yesterday. You had two pieces of string. It was supposed to cut it in half at a 90-degree angle, and then Miss McCrone and I measured from C to A and C to B. Theoretically, they were supposed to be the same, so the difference was supposed to be 0 there. And what these two theorems say, and the converse is just the reverse of the original theorem, so I don't even think I put that on your sheet. But what this is saying is you can have a point anywhere along this perpendicular bisector, and the distance to each endpoint, the distance to each endpoint should be the exact same, regardless of where that point is at on the perpendicular bisector. So you can put that point anywhere at all, and it should still be the same distance away. And then the converse of that just says, okay, maybe you didn't know this point was on the perpendicular bisector, but if you know that D to A is the same distance as D to B, then you know that it has to be on the perpendicular bisector. And I'm going to give you a hint for one of your test questions. There is a question on the test, which is a ways away, but it gives you a picture like this and says, what could you conclude about point D, knowing that these distances are the same? And you would be able to logically conclude, okay, if I know these distances are the same, then I know that that point has to be on that perpendicular bisector. All right? And so P, this midpoint, it follows the same theorem. P is on the perpendicular bisector, and it is the same distance away from A and B, which happens to make it the midpoint of the segment itself. All right, so this should be pretty straightforward. So I'm actually going to grab out my popsicle sticks here because I think you'll be able to figure this out pretty logically. So again, on this first picture, we have a segment RP and we have a perpendicular bisector line SQ. And so our theorem says any point that's on that perpendicular bisector, so in this case we have 2 points on there, those 2 points have to be the exact same distance away from points R and P. All right, so if it's the exact same distance away and they're asking for RS, I'll leave this one up for volunteers. How long do we think RS is? Anthony? 6.8. It's the exact same distance as PS. S is on that perpendicular bisector, so it's going to be the exact same distance away from those two endpoints. So if one side is 6.8, then the other is 6.8 as well. Same thing here. We have 2 points on the perpendicular bisector, F and H. In each case, F is the same distance away from E and G, and H is the same distance away from E and G. They're asking for the length of E all the way to G. E all the way to G. Michael, what do you think?
It's 19 because you have to add 9.5 to it.
Nice job. So FE is 9.5 because they're equal, but then if they're asking for E to G, 9.5 plus 9.5 is 19. Very nice. Now this last one, AD, we don't have actual numbers here. We have algebraic expressions. So what do you think I have to do first before I figure out how long AD is? What do you think I have to figure out first before I figure out how long AD is? Someone just said it. Find x. I got to find x. What kind of equation do you think would make sense here if I know that D, this point D, has to be the exact same distance away from C and A? Parker? Put them equal to each other. So something like 3x plus 14 equals 5x. Solve for x. Go ahead and solve for x real quick. Bless you. Connor, what are you getting for x here? 7 minus the 3x over, we get 14 equals 2x, divide by 2, and I would agree. I'm getting x equals 7. Now, is that the length of AD? No. What do I do with the x?
Plug it in.
Plug it in, okay? Should it matter which expression I plug it into?
No.
No, because they're supposed to be the same, so it shouldn't matter, but if you want to play it safe and go ahead and just plug it into literally AD, that's fine. So when I plug that in, instead of 5x, I would plug in 7 for x. And what's 5 times 7? 35. Now, you don't have to do this step, but I'm just going to, over here, make sure that the other side I get 35 as well when I plug in 7. 3 times 7 is 21, plus 14 is 35. So I'm good, and I know that they're both 35. Questions so far? All right, let's talk about angle bisectors. We did not do this one yesterday. An angle bisector we talked about last semester. Bisect, again, still just means cut in half. So in a formal sense, it is a ray that divides an angle into two congruent adjacent angles. Okay, so if I have a full angle and I bisect it, it's always going to be a ray, and it's just going to go right smack dab in the middle, creating two equal halves. So if my full angle measure is, I don't know, 60 degrees, and I have an angle bisector in there, it's going to cut it in half to make two 30-degree angles. And this theorem says kind of the same thing as the last theorem, except you're dealing with an angle bisector instead of a perpendicular bisector. So this theorem says, okay, any point, again, that is on the angle bisector has to be the same distance away from the two sides of the angle. Now, last semester, we talked about this kind of abstract concept of how do you measure the distance from a point to a line, right? That's kind of a weird abstract concept. How do you measure the distance from a point to a line? Well, remember, it's always going to be the perpendicular distance, because that's the shortest distance, and that's how mathematicians can keep things consistent. So when we talk about this point on this angle bisector being the same distance away from the two sides of the angle, it has to intersect at a 90-degree angle. So make sure that you understand that fact. It has to intersect at a 90-degree angle for these distances to be the same. If I were to draw a different distance, like right there, that's not at a 90-degree angle, that blue distance is not the same length as DB. It is probably longer. So the distances you're looking at have to intersect at a 90-degree angle. And then the converse of that, again, just says, okay, maybe you didn't know this was an angle bisector, but if you know that this point is the same distance away from both sides and intersects at a 90-degree angle, then yeah, those two angles have to be equal to each other. So you guys will get some questions on your homework that say, is there enough information here to say that this is an angle bisector, or to say that point D is on an angle bisector? And the two things you would be looking for are, okay, are these little pieces of segment the same length, and are they intersecting at a 90-degree angle? So in this first one, point J here is the exact same distance away because it's 7 and 7, not because of tick marks, but because they're literally the same length, and it intersects at a 90-degree angle. So that is using the converse theorem from the last page, saying, okay, if that point is the same distance away and it's perpendicular to the two sides, then this is an angle bisector right here, FJ. So if FJ is an angle bisector, they are asking, and this little angle right here is 42, they are asking for the measure of angle GFJ, right here. 42, because it's being split in half. So if one half is 42, then the other half is 42 as well. Sometimes they just ask you for the other half. Sometimes they ask you for the whole angle. So make sure you're not jumping to conclusions. Make sure you're actually reading the problem. Now, letter B, we're not looking for an angle measure. We're looking for a length of a little segment here that's perpendicular to the side. Now, I'm able to say that these are equal to each other, but only because I know for sure this is an angle bisector. Who can tell me what in this picture is indicating that that green ray is, in fact, an angle bisector? Aaliyah? The congruent angle marks right here. Nice. You see those little arcs down there? Those congruent marks tell me that those two angles have to be exactly the same, and so I know it's an angle bisector. So then, yes, these two pieces here, PS and RS, would be equal to each other just like they were with the perpendicular bisector. So what kind of equation can I set up here to solve for x? Set them equal to each other. All right. Now this is a great equation to look at because this is where I see a lot of algebraic errors. You have to move all your x's to one side and all your constants to the other. So if you're going to move 5x over, that's fine, but you don't get to shift your equal sign. So then technically what you would have is this, and then you would want to add 5 over, and you end up getting x equals positive 5. I just see a lot of errors because I'll get people trying to tell me it's x equals negative 5 because they like move their equal sign to a different spot, which we're not allowed to do. But so if x equals 5 and they want us to find RS, let's take that 5 and plug it in. It shouldn't matter which one you plug it into. So if you plug it into one of those expressions, how long is RS? I'd love to hear from someone new if I could. I can pull popsicle sticks. Michaela? 25. 5 times 5 is 25, or you could do 6 times 5 is 30 minus 5 is 25. Nicely done. Now again, make sure you are paying attention to directions because sometimes it does just say solve for x and you don't have to plug it in, but sometimes they want you to plug it in. Questions so far? We're going to use a couple more examples and then we'll give you a little bit of work time. We are not going to do the last example on the worksheet, and I will tell you why in a minute. Okay, let's go back to perpendicular bisectors for a moment. And each one of these is a new problem, so they don't go in, like they don't flow together. There are going to be some different measures in here. So as you mark the picture, you may have to mark it and erase it, just so you know. So the first problem says ZX is the perpendicular bisector. So if they're telling me that as a fact, then I know that any point on that perpendicular bisector, so there's 2 points there, X and Z, have to be the exact same distance away from W and Y. They have to be. So you're like essentially creating this nice isosceles triangle shape. It says YZ is 13.75. Find WZ. Okay, if I pull someone here. Benny, what do you think? How long would WZ be? 13.75. It'd be exactly the same. Number 2 starts the same way. It is the perpendicular bisector, so we know for a fact that these distances are the same on the bottom and then these two on the sides are the same. It says WZ is 4n minus 13 and YZ equals n plus 17. Find YZ. So let's first solve for n. So Angel, what kind of equation can I set up here that would make sense to solve for n? Caitlin, first step in solving that equation? Okay. Absolutely, we can do that. We have 4n equals n plus 30. Next step. Anybody? Connor? Subtract the n. And we get, I'm kind of running out of room, 3n equals 30. Divide by 3. I know we get the last step just fine. It's just the switching things around. I know tricks people a little bit. N equals 10. Now that's not the length of yz, but if we plug 10 in, if we plug 10 into one of these expressions, so if we plug it in here, what's 10 plus 17? 27. Very good. So yz would equal 27 for number 2. Okay, now the third one is going to use kind of the converse theorem. So this one's different because it doesn't tell you it's a perpendicular bisector directly, but it says that WZ is 20.5, WY is 14.8, and YZ is 20.5. So that converse theorem says, okay, even though they don't tell me this is a perpendicular bisector, I know it's perpendicular, and if these two segments are the exact same length, and that point Z is equidistant from the two endpoints, then it has to be a perpendicular bisector. It has to be. And then our question says, find the length of WX. Anybody have a thought on how we could find the length of WX in red?
I just divided it 2 by 2 because that's the whole thing. And I have 7.4.
Nice. Those two halves are equal. 14.8 cut in half. He said is 7.4. I would agree. Okay, it wouldn't make sense for it to be 14.8 as well because 14.8 is the whole thing. So that's just a piece of it. All right, we're going to do one more with angle bisectors, and then we're going to cross off that last example. First one says directly BD bisects angle ABC. So it is telling you it's an angle bisector. BD bisects angle ABC. It is cutting it in half. DC is 6.9. Find DA. Don't overthink it. Let's go with Aaron Cappy. DA? 6.9. If it is on an angle bisector, it's going to be the exact same distance away as long as it's intersecting at a right angle, which it is. We have those right angles on the sides. Second one starts the same way. BD is for sure an angle bisector. It says AD is 3Z plus 7 and CD is 2Z plus 11. Find CD. I think you're all catching on to the fact that for most of these equations today, we're going to go ahead and set them equal. If you added them, it wouldn't make sense because you would have nothing to set them equal to. And you already answered today. Let's go. Tristan, what'd you do first for the algebra here?
7 equals 2.
Sure, and then how'd you solve it?
I subtracted 7 first.
And then minus the 2z over. And we get 1z equals 4. You can put the 1 there and divide by 1, but dividing by 1 is an identity property, so it doesn't actually do anything to your number. Z is 4, and I plug 4 into one of these expressions to find the length of CD. Ada, can you tell me how long CD would be if I plug in 4? So what's 8 plus 11? Very good. Lovely. 2 times 4 is 8, plus 11 is 19. Okay, the last one, just kind of like the last slide, does not directly tell us it's an angle bisector, but it says that AD is 3.2, CD is 3.2, so let me just stop right there. If those distances are the same and they intersect at a right angle, then automatically this is going to be an angle bisector. It says angle DBC, DBC is this angle here, is 39 degrees. Let's be careful what it's asking for. It's asking for angle ABC in green. Thoughts? Where'd 78 come from? I cannot hear you, sorry.
He added 39.
I added 39.
Okay, because if both angles are equal, because it's an angle bisector, 39 and 39 put together is 78 degrees. Very good. You have to be real careful about which angle. I know angles are tricky too with all the letters, but you have to be real careful about which angle it's asking for. Okay, cut the last one for 2 reasons. Number 1, you don't actually have to do it in this section, but number 2, if you read the problem and read the directions, the answer is actually on the picture. It says write an equation of the perpendicular bisector. The equation is on there, so that doesn't make any sense. Okay, so we are in here until like 9:07, not 3:07, sorry, 9:07, and we are going, I'll hand out the worksheets, and we'll get started.